Today we're going to talk about ellipses. And ellipses, what you want to do is you want to just think of ellipses are squished circles. So just a couple different things you need to know about an ellipse. Ellipses are not equal distance from the center, but you'll have a center in an ellipse, and then you'll have another point, and this point here is called a vertex, and you'll have another vertice on the other side of the ellipse. And we'll have what is also referred to as a covertice, and we'll have two of those covertices. Okay, so when we have a ellipse, we in mathematics will have different letters to stand for different things, but you'll need to know that A is the distance from the center to a vertice, and mathematically we use B is going to be the distance from the center to what we call the covertice. So if this distance is 5, then we'll go 5 to the right and 5 to the left from the center. And if B is equal to 2, that means that we would go 2 up and 2 down, and we'll draw our ellipse. So different than a circle is equal distance from the center. Here we're not going to have equal distances. So take a minute, make sure you get down those notes, and then I'll show you where these A's and B's come from. So let's start off with an example of an ellipse. An ellipse is going to have an x squared and going to have an y squared, but instead of it equal to the radius squared, an ellipse will have equal to 1. But there's a little bit something extra in an ellipse. We'll have a number underneath the y, and we'll have a number underneath the x. And those represent which way we move in which direction. So what am I saying? Let me give you an example. So if I have an x squared over 4 plus a y squared over 1 equal to 1, and then again an ellipse will be in this fractional form. A will be the distance we move in the x direction, and in this case B will be how far we move in the B direction. So just like with the radius, we'll take the square root of these numbers. So let me just draw you a quick little sketch over here. And you want to draw with me. So again, like the circle, we have no values with x and y, so we'll have a center at 0, 0. And since this number underneath the x is 4, this tells us to move in the x direction 2. So we'll move 1, 2. This will give us a vertice. We'll move 2 in the other direction. This will give us another vertice. Now we'll move this number in the y direction. So the square root of 1 is 1. So we'll go up 1 and we'll go down 1. How do I know which direction to go? It's underneath the y, so we'll go in the y direction. These are what's going to be referred to as the covertices. And then if we connect these 4 points, we will get our ellipse. So again, I want you to make some notes here. Make a note that whatever this number is, you move in the x direction, which the x direction is right and left. And since this number is underneath the y, this is how far you move in the y direction. Make a further note, the vertices are always the longer side, and the covertices are always the shorter side. So again, take a minute, make sure that your notes have all this information in it. And I'll give you another example and ask you to draw it. So I'm going to give you a x squared over 25 plus a y squared over 4 equal to 1. And again, what you'll notice is that this will be an ellipse because we have different numbers. And these numbers will tell you in which direction we move. Right now, we'll just start off with the center being at 0, 0. Since this number is underneath the x, this is what direction we'll move in the x direction. Not 25, but the square root of 25. Label this vertice. And this is the vertice. We have, we're going to move in the y direction, whatever the square root of this number is, which is 2. So we'll go up 2, covertices, down 2, covertices. Again, connect these 4 important points with a smooth line, and that will give us our ellipse. You'll be asked to identify the vertices, which means that you'll label those, and you'll be asked to label the covertices. One other vocab word is you'll be asked about what's called the major axis and the minor axis. The major axis is going to be 2a, or think of that as that's going to be how long this big axis of symmetry is. So in this case, 2 times 5 would be 10. And the minor axis will be the smaller one. It's 2b. And in this case, 2 times 2, the minor axis would be equal to a 4. So how do we label the axes? If we're on the x-axis, we would label this point 5, 0 and negative 5, 0. We'll label the covertices going up and down. We'd get a 0, 2, and a 0, negative 2. Now, the last thing that we'll discuss is sometimes the ellipse will go the other way. So let me give you an example of that. If I have an x squared over 4, let's say, over a y squared over 9 equal to 1. This looks like the same, but it will kind of turn out a little differently. Let me show you why. We have a center still is going to be 0, 0, because we have none of that. This 4 is underneath the x, so this is how we'll move in the x direction. So we'll move in the x direction 2 and the x direction both 2 and 2. But this time the 9 or the bigger number is underneath the y, but we'll still move in that direction. So we'll go 3 in the y direction and 3 in the other y direction. Okay? And then our ellipse, what will happen, since we're going further up and down than we are right and left, our ellipse will be a vertical ellipse. And so when we label these 4 important points, it's not a big deal when we graph, but this is our vertices, and these will be our covertices. Okay. And again, how are you going to keep track of that? Look back at your notes and make sure that you labeled the vertices are the largest and the covertices are the smaller. That's how you know. So you'll just have to look at these numbers, and this will tell you if the big number's underneath the y, it'll tell you that you have an ellipse that goes up and down more. And if the bigger number is underneath the x, you'll have an elongated ellipse going the other way. Major axis and minor axis will be the same thing. Okay. Remember, the major axis is 2a, and the minor axis is 2b. 2a is the longer of the sides. So since this is the longer axis, this was 3 and this was 3, so 2a will be a 6. The minor is the smaller axis. Since this was 2 and this was 2, the minor axis is 2 of those, which you'll get a 4. Okay. You'll be asked to label the vertices. This time the vertices will be going in the y direction, and the covertices will be going in the x direction.